record. Okay, you are given that says fig 8 shows that hot air balloon, okay, on each side, the balloon is modeled by the volume of revolution, okay, which I'm sure you haven't done. We'll skip that. Now find the, okay, about the x-axis, okay, like that. Then you're given that x is equal to that and y is equal to that. Okay, are we together? Then the first thing I think that they're going to ask you is to find dy over dx. Dy over dx. So, by parametric equations, what I can calculate there is to find my d. Look at this. So dy over dx, that's what we want to find, will be equal to dy over d theta. So I integrate with this with respect to theta, multiply by d theta over dx, the inverse of dx over d theta. Can you see? So that this cancels and you have dy over, makes sense? That's all you do with parametric. So it means there I can find my what? dx over d theta. And I know that if I differentiate this was a constant, it gives me 0. Are we together? If I differentiate sine, sine gives you what? Cos theta. That's true, if you remember that. So this is simply 2 cos theta. Make sense?
Yes.
Yeah.
But say,
yes,
2
is a constant. It doesn't change. It's 2 multiplied by that.
Oh.
So I'm differentiating. It's this that I'm differentiating. It gives me what? Cos theta. So multiply by 2. That doesn't change. Are we together then?
Yes.
It's like, for example, if you have y is equal to x to the power 2, x to the power of 5. If I say dy over dx, can you see that this 2 is a constant?
Yes.
This will be 2 multiplied by what? The differential of this. Can you see that?
5.
Which will be 5x to the power of what? 4.
4.
So it's the same thing there. Now let's differentiate this. So dy over d theta is equal to, so I can differentiate now by what? By parts. The first one, what is differentiation of sine theta? Of course, theta, sorry, should be negative if you check in a formula booklet. Negative sine theta. So this will be minus 2 sine what? Theta. Can you see that? Plus, now I know that cos theta, differentiation of sine theta gives me cos theta. But there I have a 2. Huh? You see this? So I have to think of chain rule. I think of this just as a single. Huh? If I say let x be equal to, let 2x, I could have said let x be equal to 2 theta. Are we together? Makes sense? Yes. So what I do is I differentiate this. You think of this as a single sine theta. If you differentiate this as sine theta, you get cos theta. But this is not cos theta. This is 2 cos what? Theta. So it will give you cos 2 theta. Then you differentiate what's inside. What's differentiation of 2 theta with respect to theta is simply 2. Are we together? Oh, yeah, lost.
Yes, sir, we are together.
I'm showing the shortcut. So that's the dy over d theta there. So now remember we said this. It's dy over multiply by that. So it means dy over d theta is this whole thing. It's minus 2 sine theta plus 2 cos 2 theta divided by, so it's the inverse. So we are dividing by 2 cos what? Theta.
And 2 cos theta.
Because we're saying inverse of this by 2 cos theta. We are done. That's what they wanted on the first part there. Find dy over dx. Huh? Then now they're saying verify that dy over dx is equal to 0 at the turning point when theta is equal to that. Huh? So we are now saying if we equate this to 0, can you see that we lose this? Make sense? So now that what's left is minus 2 sine theta plus 2 cos 2 theta is equal to 0. Make sense? Take the 2 cos theta the other side, you're left with this side with 2 cos 2 theta is equal to what? Is equal to sine 2 sine theta positive. Divide both sides by 2, and I have cos 2 theta is equal to sine what? Theta. What is cos theta? Remember, if you want, what is cos? We can represent cos in terms of sine only. Check your booklet. I think it says 1 minus 2 sine squared. Just check the identity. Cos 2 theta. Cos 2 theta has got two identities in your booklet there. The first one, I think it's 1 minus 2 sine squared theta. The other one is 2 cos squared theta minus 1. Just confirm there in your booklet. Yes. So there you replace this. Huh? So this is 1 minus 2 sine what? Squared theta is equal to cos what? Theta. Sorry, it's equal to sine theta. Sorry. Are we together? We've just changed this. Then bring everything one side. You rather move this the other side so that you have all positive. You have this as a positive. So it will be 2 sine squared theta plus sine theta, because I've just moved everything to this side, plus sine theta. Then this becomes minus 1 is equal to 0. Are we together? Then to make things easy, you can say let x, I'm sure that's what you do at school, be equal to sine 1 theta. So that I have 2x squared plus x minus 1 is equal to what? 0. Clear?
Yes.
Can it be factorized? Before we think of completing this way, let's see. Was 2x, it's only 2x multiplied by x. Huh? This is a 1, huh? So it's possible. So this is positive 1 and this is negative 1. Are we agreeing?
1.
Yes, because that gives us 2x and that gives us negative x and that gives us x there. So that's true. So which means x is equal to minus 1 or half. But we know that x is equal to what? X is sine theta. So I'm now saying sine x is equal to sine theta, sorry. We use theta there, not x. Sine theta is equal to minus 1 or it's equal to half. Are we together? Then we do arc sine. Remember, we want to prove this. Then we do arc sine. So theta is equal to arc sine of minus 1 or arc sine of half. What do you get? Remember, it's radians. Huh? Your calculator has to be the radians. Negative 90 should be 270, which is 3 pi over 2. Or half is 30 degrees. Pi over 6, huh?
For arc sine minus 1, it's negative pi over 2.
Negative?
Pi over 2.
Negative pi over 2.
Yes.
Okay, that's fine. Yes, or 360. Or this one definitely is the one that we want, which gives you pi over 6, huh? Because that's 30 degrees. Are you together?
Yes.
That's what you wanted. So you have proved, yeah? Make sense? And find, hence find the exact coordinates of B. Verify that theta is equal to when now. Where is B? B is a turning point. Huh? So it means we have verified that the x coordinate We're saying theta is equal to that. Okay, that's fine. So this is our x and our y is our equation. So they're now saying hence verify. So this is the turning point, like what you said. You know that at the turning point, we are using theta is equal to pi over 6. So to use to find the exact coordinates, we can use this. Okay, go back to the parametric. We have found what the value of theta is. Are we together? Theta is what?
Pi over 6.
So can you plug pi over 6 there so that we get the x value there? 2 plus use your calculator in the radians so that we find the x coordinates.
The x coordinate is 3.
Okay, 3. Then find the y there of b. But it has 2 values, which means it has a positive and a negative. Okay.
(2.2).
I hope we discover that this is 2 times, 2 times whatever your sign is.
Yes.
So you're saying what's your answer?
2.2.
Exact 2.2.
2.208157827.
Doesn't give you the answer as a set form or something. Because if it says exact, it means your answer, you can't do that. Your answer has to be in set form. So let's look at this. Sine, if we say 2 times pi over 6, what do you get? 2 times pi over 6 is sine pi over 3. Are we agreeing?
Yes, pi over 3.
So what is sine pi over 3? Plus 2 cos.
It's root 3 over 2.
Yeah, that's what you want. So this is root
3 over 2.
Over 2. And this side, 2 plus cos pi over 6. 2 times the first part there. 2 times cos pi over 6. Root 3,
Root 3.
So you see, when they say exact value is root 3 plus, that's what you do, plus root what? What did you say? Root 3 over?
3 over 2.
Over 2. Okay. Root 3 over
2.
2 is the common denominator, so it's 2 brackets 2 root 3 plus root 3, Are we agreeing? Yes. And you add this, you get 3 root what? 3 root 3 over 2. So it means those coordinates is 3 and 3 root 3 over 2. That's what they mean by exact values. Clear?
Yes.
Okay, we have done that. Hence, find the maximum width. Oh, we didn't see that. Hence, find the maximum width of what?
Of the balloon.
Did they say of the volume? Of the width of BC. That's the last part. Width of BC. Oh, all the way to C. So it simply means you are finding distance.
Yes.
Anyway, you find that this point again will be
the turning point.
Will be the same turning point on the same points. So which means it will be simply 3. What was this one? This coordinate? The one that we wrote down?
It was 3 root 3 over 2.
Okay, let's just wrap this so that it is simply distance between 2 points. Are we together there?
Yes.
Now, we said this was 3 brackets 3 root 3 over 2. And this turning point will be 3 brackets minus 3 root 3 over 2. Are we agreeing?
Yes.
Then distance between 2 points, you know that change in y over change in x.
Yes.
So the change in x gives you 0. We can ignore that. Can you see that?
Yes.
Is this change here, which will be 3 root 3 minus will give you what? Positive. Plus 3 root 3 over 2 all squared. Are we together? Square root. Make sense?
Yes.
Because I say this minus that squared, then I say square root of that. Square root simply takes away this. So what is 3 root 3 plus that? What do you get?
We get 27.
Oh, you've done that already.
Yes.
27. Okay.
Yes.
2 is the same, so it will be 6 root 3 divided by 2. Okay. Now, show that y is equal to x cos theta. Show that y is equal to x cos theta. How many marks is that? Hence, find sine theta in terms of x. Is this the same question? Okay. Let's wrap certain things that we know. So it's a long question. Yeah, but in an exam, they won't give you. But this is good practice for you there. So what do you do? Show that y is equal to x cos theta. Y is equal to x cos theta. What do you do there? What do you do? But look at your thing. You can apply y is equal to x. It means whatever the value of x times cos what? Cos theta.
Cos theta.
So you can pick it from here. Because we want to prove that y is equal to x cos theta. Y is equal to x cos theta. So what is x? Let's pick it from there. What is x? Look at this. So don't complicate life. X is equal to what? 2
plus 2 sine theta.
2 sine theta. Multiply by what? Multiply by cos theta.
Theta.
You see, it's not difficult. You see that multiply there, you get what? 2 cos theta plus 2 sine theta cos theta. It's not difficult. Can you see that? Then check your identities now. This identity gives you exactly this. You are done. Are we together? So
Identity.
check the identity there. Check what 2 cos theta is. Sine 2 theta in your book is 2 sine theta cos theta. You're actually done there. Did you see the identity that I'm talking about? Sine 2 theta on the double angle. Sine 2 theta there. 2, yeah, it's this. So you're done. You have proved. How are you together?
Yes.
That was not difficult at all. No. Hence find sine theta in terms of what? Of x. Sine theta in terms of x. Sine theta. So look at this. This, when they say hence, it means you get help from where? From there. Are we together?
Yeah.
You get the assistance from this. Y is equal to x cos theta. It means straight away from this, x is equal to y divided by cos what? Theta, if I want to put it that way.
Yes.
Okay, hence express fine. Okay, wait a moment. Hence find hence. Okay, find x in terms of theta. Okay, fine. Sorry. Okay, show that this way of shown now is different. I didn't see that. Find sine, express sine theta in terms of x. So let's go there. Where is sine theta in terms of x? This one, huh? Can you see that?
Yes.
This is the one that is easy. So let's do that. So it means x minus 2 is equal to 2 sine what? Theta. Then sine theta, that's not difficult, huh? Is equal to x minus 2 divided by 2. Are we agreeing? There.
Yes.
That's what they're talking about. Now, they are now saying, show that cos squared is equal to x minus that divided by that. So we are going to pick it from there. Huh? Cos squared. I'm sure you can see where the cos squared is going to come from this jargon there. Are we together? So we now know what sine theta is. We also know that y is equal to what? What do we know?
That
Y is equal to?
x cos theta.
So it makes it interesting. Huh? So it means there I can replace it with the x what? X cos theta is equal to 2 what? 2 cos theta. Are we together? Now, sine there, what is sine? We said sine is what? Remember what we said?
2 sine theta. Cos theta.
Is 2 sine theta cos theta. Okay, but we know what, so we now know what sine theta is. Huh? Can you see that? What do I do before that? Can't I divide everything by cos theta?
Yes, you can. Just in an x.
We can, huh?
Yes.
But we want to show cos squared. Let's see. When do we lose the cos squared? No, we can even do that. Now let's divide everything by what? By cos. So we this side we're left with x, huh? Is equal to what? If we divide by cos, there we're left with 2, huh? Plus 2 sine what?
Sine
Theta. Is that true?
Yes.
Okay, it's fine. I'm just looking at something here which is not making sense to me. Okay, that's fine. Okay, 1 minus. Okay, we want to prove that cos squared. Okay, so what do you do there? We can find the sine theta. I'm just looking at this. Yes, we can find the sine theta. Let's do the sine theta anyway. Okay. It was not even necessary what we did, because we had the sine theta here. Can you see this? We know that, anyway, even from this we can find it. But it was not necessary because we know that this is sine what? Sine theta. So what is sine squared theta from this? Remember what I wanted to prove is this, is to show this, that it gives you that. So now, all I do is I find the sine squared. Sine squared, okay, sine theta, let's write it in another way. If I divide this, I'm going to have what? X minus 2. Can you see? I'm dividing everything by 2 minus what? Minus 1. Are we agreeing? Then sine squared theta is simply equal to x over 2 minus 1 all squared. Are we agreeing? I have squared this, so I have to square this. But I know the identity that 1 minus cos squared theta, both sine squared plus cos squared is equal to 1, is equal to sine squared theta. So it follows that the cos squared theta will be simply, this 1 will become a positive. That's correct there. Yes. This 1 will become a positive, and this will be like this.
Yes.
Is that true?
Yeah, yes, making sense. Yes.
Making sense or not making sense?
It's making sense.
It's making sense. Okay. Now let's see if it will reduce to this. Just need to check something quickly here. We said this is what, if we were to take it back, it will be 2 minus x, is that true? Divided by 2,
Yes.
Combined. Now if I square this, yes, I get the 4 squared part. I'm just checking. This is x. Okay. I'll show that this is equal to that. Okay, wait a moment. Divided by 2. Then we said that, okay, that's fine. Okay, I see what we could have done there. Can you see what we could have done here? We could have squared individually. Are we agreeing? It's the same thing, We could have squared even individually. We will have sine squared theta is equal to x squared over 4 minus what? Minus 1.
Yes.
I'm just wondering where the x is coming from. Unless I missed an x sum. X minus 2 divided by 2. Okay, figure 2. Anyway, that's how we show it. I think we might have missed something small there. Hence, show that the Cartesian equation, you work it from there. The Cartesian equation of what? Y squared is equal to what? That minus that, So what is y? They're saying y squared. Y squared, remember I said y is equal to what? From here. Y is equal to x what? So if it's y squared will be equal to x squared cos squared x, which will be equal to what? X squared multiplied by, you see this, multiplied by what is cos squared there? It's x minus what? Minus 1, okay, or minus x squared over 4. Remove the brackets, you get x cubed minus x to the power 4 over 4. Are we together?
Yes.
Makes sense?
Yes, sir.
What a long question. Anyway, it's worthwhile for you to revise these things and to understand parametrics. What's the time now? Let's maybe we might have time to have 9 minutes. Oh, I think the time extended because if it's one person, it will extend to more than 40 minutes. If it's one person, there's no limit because the software is expensive. But if it's two or more, it cuts it exactly 40 minutes. That's why it didn't cut there. Okay, just need to see if we can do this first part quickly. We'll give you 10 minutes break. Now, we can verify that x is equal to that and y is equal to that. Parametric what? Equations of which curve? Of this curve. So how do you verify something like that? 3 marks. It means if I substitute these values, my equation there should be consistent. Are we together? Well, this is my value of what? Of x. If I substitute that and I substitute the value, I should get exactly k squared. So let's do that. X squared will be x cos what? Theta squared. X squared means x squared plus x squared. Plus 4 multiplied by what is y? It's half what? K, are you there?
Yes.
Sine theta squared, was this? Now, if we square this, we get k squared cos squared, cos squared theta there. Plus, what is half times that? 4 times, it's 4 brackets. What is half squared? It's a quarter. We have k squared sine squared theta. Are we agreeing? Quarter times that gives you 1. I'm sure you see that it's coming up. So it will be cos squared the theta plus this simply gives you 1 k squared sine squared theta. Factorize k squared, you now get cos squared theta plus sine squared theta. We know that this gives you 1. So simply k squared plus 1. Done. Are we together? Clear?
Yes.
Now let's do this as the last part, the hence part there. Hence, you now have an idea. Show that dy over dx. So ideally, you now know we find dy. That's what we said. So this is in terms. So let's find the dy over dk. Can you see that? Because we have k there. Oh, sorry, d theta. Sorry, dy over d theta there because we have theta. I didn't see that. So what is dy over d theta here? Then we also find dx over d theta. Now dy over d theta, this is a constant, remember? Doesn't change. What is integration of sine? You said it's cos. So it's simply half k cos theta. Are we together?
Yes.
Then this one It's negative sine theta. So it's simply equal to minus k sine theta. But we know that dy over dx will be equal to dy over d theta multiplied by the inverse of d theta over dx. Okay, so dy is this one, which is half cos theta multiplied by the inverse, which is 1 over negative k sine what? Sine theta. Can you see that? Oh, I left the k there. Sorry about that. This k. So the k cancels out. Are we together? And we get a minus what? But this is half. So we are multiplying by that. So we get a cos theta on top. I'm sure you're agreeing there. Then this half stays there. Sine what? Negative. Sine theta. Okay, like cot. But now, look at this. We are almost done. I'm sure you're saying, but how come there's no cos theta, there's no what? Now look at this. What is cos theta here? This is where I play with maths now. What is cos theta here? Make cos theta, let's have the formula. Cos theta, x over k.
K.
What is sine theta there? Make sine theta, let's have the formula.
Y over.
Remember, you can multiply first, then you get 2y. Yeah? So sine theta is equal to, because if you multiply, you get 2y. I'm sure you saw that. 2y over k, yeah? Are we agreeing? Because remember, this is half. I multiply both sides by 2 first. So now I do my substitution into this. So cos theta there is x over k. Are we together? Divided by 2 times, what is sine theta? Is 2y over k, yeah? Are we together? Which is as good as x over k multiplied by the inverse of this, which is k over 4y. Remember, there's a negative there that I left out there. Make sense? K cancels, k cancels. What a nice equation. Shown there. Minus x 4y. See, these equations are very nice. Are we together?
Yes.
Okay, 10 minutes break.